For today's activator, if I give you that vector A is equal to the vector 8 comma negative 6, can you determine the magnitude of the vector? Can you determine the direction angle of the vector? Take a couple moments, attempt this problem, unpause the video, and we'll go over it. Welcome back. You should have had a chance to attempt this problem. We're going to go ahead and take a look at how we would go about determining the magnitude and the direction angle. If we think about this particular vector, we could kind of draw our axes, and I could think about this as a point that's out 8, negative 6. It's going to be the vector represented by the arrow that goes to that point, 8, negative 6. All right, and if we think about the magnitude of this vector, well, we can just create a right triangle. We can use the Pythagorean theorem. It would just be 8 squared plus negative 6 squared equals c squared, or the magnitude squared. 64 plus 36 is c squared. So 100 is c squared. So we take the square root and we get 10 equals c. So the magnitude of A, which we would write like this, we would write the magnitude of A is equal to 10. All right, that kind of tells you the length of the arrow that represents the vector. If we wanted to determine the directional angle of this particular vector, we could go ahead and we could use some trigonometry. We could say, hey, here's my reference triangle, here's the angle theta, and I want to know, I know that this x distance is 8, I know the y distance is 6, and we could say negative 6, and I know that the hypotenuse is 10. We could use any of our trig functions, and I could say, it's the inverse tangent of negative 6 over 8, or the inverse sine of negative 6 over 10, etc. And we could plug in any of those trig formulas, and when we do that, we would get that our value is going to be the inverse tangent of negative 6 divided by 8 would give me approximately negative 36.9 degrees. Now, when we think about the direction angle of a vector, right, we could think about it as negative, going down into quadrant 4 that way, or we could think about it as going around from the original positive x-axis, which would then be 360 degrees minus that answer, or plus that answer, I guess, that negative value, and we would end up that angle would be 323.13 degrees. So you could go about it either way. Just note that typically when we look at the direction of a vector, it's going to be from the positive x-axis. How far would you go around to get there? So that would be the positive value. The negative value would be fine as well, because they both are referring to the exact same direction.